Okay, so the problem I'm doing today is number 51 of chapter 7, which is in a popular amusement park ride, a rotating cylinder weighs 3 meters is set in rotation at an angular speed of 5 radians per second, as in figure P7.51. The floor then drops slowly, leaving the rider suspended against the wall in a vertical position. What minimum coefficient of the friction between the rider's clothing and the wall is needed to keep the rider from slipping? So first, we need to draw a picture. So we have the ride, and then we label our axes. So there's a y plus, the y negative, the x positive, and the x negative. And then this normal force here represents centripetal acceleration. Given that normal force is what's causing centripetal acceleration, going at 5 radians per second, and it's 3 meters. So first we need to find our centripetal acceleration, which is w squared r. Solve that, plug in, you get 700 meters per second squared as your centripetal acceleration. Next, we need to find the sum of our forces, which is sum of forces x, which would just be centripetal acceleration. So, mass times acceleration, and given that it's only centripetal acceleration, we can just go right ahead and just say it's mv squared over r. Because the only force is the centripetal acceleration, which is also caused by the normal force. So we can label that the x direction is also the normal force. Next, we need to do our forces in the y direction, which equals, if you don't remember, we should probably label in our free diagram. This would be the friction of the normal force, and this will be your weight, which goes in the negative direction. So you would get normal force minus mg, and since you're not moving, it's 0, which you could solve to be yn equals mg over normal, and this is your normal force. So as a result, you would combine the two equations, and it would be something like this. Equals mg over, so we plug this fn to where that is, so that'd be mv squared over r. The m's would cancel out, it'd be g over v squared over r, like that, equals 9.8 meters per second squared. If you don't remember from our previous lessons, v squared over r equals w squared over r. They're all centripetal acceleration. We plug in our centripetal acceleration from before. You solve that, and that equals 0.131 as your coefficient of friction. Oh, okay. Well, that is the problem.